There we go. All right, so we know that the sum of the interior angles of a triangle is 180. Do you notice what happens when you draw a diagonal? Makes two triangles. How many degrees are in this triangle? 180. How many degrees are in this triangle? So together, they're 360, right? All of these are going to be multiples of 180 because everything is based on that. Okay? So, let's think about it. We know, so n is the number of sides. That's the thing we're going to learn today. So the sides, we're going to call that n. N, all right? So when n is 3, we know that's a triangle. 3 sides, 3 angles. It's 180 degrees. 180 degrees. 4 sides, 360 degrees. Actually, let's see. 5 sides, 540 degrees. We're just adding 180, right? Will you tell me how many you know? 360 plus 180? Is it 540? Okay.
Wait, 360 plus 180.
Plus 180 is 540, right? So all these are multiples of 180. The problem is, we don't want to have to start just adding 180, right? What if we wanted to know the sum of the interior angles for a polygon that has 18 sides?
180 times 18.
We can't do 18, right? 3 times 180 times 2 would not be, right? Then we're going to figure out here, what could the formula be? Because we do need a formula. Because that's what we're going to be doing. We might be finding the sum of the interior sides of a 80-sided figure, right? So let's figure out if we can figure out. So 180, that's 1 times 180, right? 2 times 180. 3 times 180. But how does that help us if I know the size?
Why can't we just subtract 2?
Always subtract 2, right? So 3 minus 2 is 1. 1 times 180 is 180. That's the sum of the interior angles of a triangle. 4 minus 2, huh?
Why we use the number 2?
Because that's the algebraic rule that works, right?
Why can't we just do 180 times 18?
Times 18.
Well, like you said, how many? You said 18.
Okay, so 180 times 18 would be too many, right? That would be like saying, for a triangle, you could say 3 times 180. But 3 times 180 is not the sum of the interior angles of a triangle, right? That's the sum of the interiors of a 5-sided or a pentagon. So we're just figuring out the rule, which is really just an equation or a formula. That's what we're doing now. I'm going to give you the formula, but really all you need to know, however many sides there are, subtract 2 and multiply by 180. That's all that terrible sounding thing means. That's all that means. Polygon, angle, sum, theorem. That's all it means. Okay? So if there was 100 sides, we subtract 2. What's the sum of the interior angles of a 100-side figure going to be? What's 100 minus 2?
90.
Can you multiply 90 by 180 for me?
17,600. Well, isn't that too much too?
No.
Well, 18 times 8 plus 80.
So if it has 18 sides, and you multiply by 180, it'll be, that is not the right number of angles in the polygon. Remember, everything is based on multiples of 180, and really it's based on how many triangles you could draw in that figure, but that's too confusing. So no matter, if you'll try to remember these two is where the rule is the most obvious. All right, easy math. If we have 3 sides, we can't multiply Because that's not the number of degrees in a triangle, right? So, the formula is going to be n, which is the variable we're going to use for the number of sides in a polygon. We're going to always subtract 2 and always multiply by 180. So we're going to get to that in a second. Right now you're writing this. Polygons are named by the number of their sides. Mark, set, go. Quick as you can. Polygons are named by the number of their sides. We know this one is triangle. Try for 3, right? That polygon name tells us how many sides there are. Tri, we know, means 3. The tripod is something with 3 legs. Triangle is a polygon with 3 angles and 3 sides. Polygons always have the same number of angles and sides. Does anybody know any of the other names of the name of a 4-sided figure or an 8-sided figure?
Square?
Jamari, tell me what you're talking about. Quad is 4. So what is a 4-sided figure called? Quadrilateral, yep. After these two, everything is in gone. Gone is the number, is the word for, or the suffix for sides. This is an 8-sided figure. How many of y'all are learning to drive right now? What road sign has 8 sides, Yuri? What road sign has 8 sides? Sorry? A stop sign, right? What do we call the shape that has 8 sides?
Construction sign.
Octagon, yeah. How that's not helpful. I didn't hear, but thanks, probably good. Okay. Anybody else know any of these sides? So how many sides does a pentagon have, Corey? It does. And let's not blurt out. Raise your hand if you know another one. Sharad?
Hexagon.
Hexagon. How many sides does a hexagon have?
Yes.
It does. Very good. And a hexagon kind of sounds like a sixagon, for those of you that didn't know that. It's not a sixagon. It's a hexagon. But that's one way to remember it. Anybody know what you might call a polygon with 10 sides?
Pentagon?
No, that's 5. Pentagon is 5 sides. Dominic, say it again. Decagon. DEC, think of a decade as 10 years. A decagon has 10 sides. Anybody know what a 7-sided figure is called? I didn't know either. I wanted to call it a septagon, but it's a heptagon.
We have to memorize this?
Yeah, a 9-sided figure is a nonagon. Kind of sounds like a ninagon, right? Ninagon, nonagon. You got to think of some way to remember them. Now, we're not going to have a vocabulary test on them, but they're going to use these words in these problems, and you have to know how many sides that name tells us we need, right? Y'all going to stop talking. Carlin, pick your head up, bud. All right, there's no sense in me trying to have you guess this one. This one has 2 names. The only one that makes sense to me is a undecagon. Un for 1, dec for 10. 1 plus 10 is 11. Undecagon. Dodecagon is 12. No trace decagon. That's a triangle. Oh, trace decagon would be 13. Yeah. Actually, I have no idea what a 13-sided polygon is called, Corey. We don't have to know anything past 12. Anything past 12 are going to be the easiest ones because they're going to be the number and gone. So a polygon with 19 sides, we're going to call a 19 gone. A polygon with 100 sides, we're going to call 100 gone. Because that's what we got to do. All right, y'all caught up with me? All right, so we're going to use, if we run out, I'm going to finish this video and y'all got to watch it at home, so let's not run out of time. The sum, you don't have to write the blue part yet, I'm afraid we'll run out of time. If we have time, I'll let you come back and write it. The sum of the interior angles of polygons also depends on the number of sides the polygon has. So the name depends on it, but also the sum of the interior angles, and we've already touched on this already. So this is the formula I was telling you. If n is the number of sides, you have to write the red. Go ahead and write the red. If we have time, we'll come back and write the blue. So we're going to call the sum of the interior angles S when we plug it into our formula. N is the number of sides minus 2 times 80. Just like a triangle we talked about. 3 sides, 3 minus 2 is 1. 1 times 180 is 180 degrees. That is the sum of the interior angles of a triangle. Looking at example 1, if we want to find the sum of the interior angles of a nonagon, is that a nonagon or a ninagon?
Nonagon.
It's a nonagon, but how many sides does it have?
9.
9. So let's write n equals 9, and then we're going to plug into that formula. So S is what we want to know, the sum of the interior angles. We replace the n with a 9, and we can do we can do it just like that on our calculator, or you can subtract it, 7 times 180. And now we know that the sum of the interior angles of a nonagon is 1,260 degrees. Here we get to the easy ones. There's nothing to remember. A 19gon. So if we want to find the sum of the interior angles of a 19gon, we just replace the n with 19. That's 17 times 180, which is 3,060 degrees. So we can use this formula to find the sum of the interior angles. If they give us the S, then we could use it to solve for the number of sides. Right? So here, looking at example 3, the sum of the interior angles of a convex polygon is 1,620 degrees. How many sides does it have? First off, a convex polygon, I'll show you some pictures tomorrow, but all of ours that we work with are going to be convex. Don't be confused by it. It just means that all the vertices point out, and I'll show you the difference tomorrow. So now, with the formula, we know what S is already, so we're going to plug in for that. What we don't know is the N, so that's what our formula is going to look like when we plug in our given information. Now, there's a couple ways to solve for it. I'm going to solve by distributing the 180 on the right side first. You ready? You're writing what I'm writing, buddy. So, and then we're going to add 360 to both sides. And now what are we going to do?
Divide
By?
at 180.
Beautiful. So now we know that this polygon has 11 sides. Yes, Kyle? It's the same difference, yeah. It's not any easier or harder, but yes, you can. That's not what we're going to do. You can do that. That's not how I'm going to put it up there, but yes. It's algebraically sound knowledge, you do it that way. If you prefer, you can do it that way. All right, same thing here. How many sides does this have? Well, instead of 1620, now we plug in 3600. We're going to distribute to get rid of the parentheses. We're going to add 360 to both sides. And we're going to divide by what?
180.
180. So now this is a 22gon. You don't have to know. This one was an undecagon. It didn't ask that though. You just have to tell them the number of sides. But you have to recognize the name of the polygon so you know what end to plug in sometimes. Kyle?
Wouldn't it X instead of X it would be N? N equals 22?
You're right. I forgot to change the N. Thank you very much, Kyle. Make sure you put N there, not X. For some reason, when I first typed it in, I typed in X, and I thought I corrected it all, but I did not. Good job, Kyle. I definitely know you're paying attention. Good job. All right, let's go on. These are the easy ones. They don't look easy. All four of those angles, so those are angle measures. This is a polygon with 4 sides. We know that 93 plus 88 plus 42 plus x has to equal what? Not 180.
360.
It does have to equal 360, but let's say you forgot it. You can use your formula, right? So we can use our formula there. If we know it's 4-sided, 4 minus, so we're going to plug in the 4. So 4 sides we should start remembering is 363, right? But if you forget, use your formula, and now we know that 93 plus 88 plus 42 plus x equals 360. And I think those add up to 223. I kind of skipped a step here. I should have not skipped a step. Kyle?
So, since we already know that 4
You do not have to do this part if you already know it. Right. So if we subtract 223 from, I think it's 223 from 360, we get 137. That is the measure for the measure of angle x here. All right, so far so good? Same thing here, but now I don't know that, right? So, but we do know how to find it. We can plug it in here, and y'all can just do this part. You don't have to do the formula every time. I'm reminding you that I can't see the formula, but you don't have to do that, but you should write this in your notes. So it's 4 times 180 is really what it amounts to, right? So we know that all of these angles, there's 6 sides, there's 6 angles. We know that they have to all add up to be 720. Right? So 4x plus 4x plus 2x plus 20 plus 2x plus 10 plus 3x minus 20 plus 3x minus 10. All of these algebraic expressions represent the measure of these 6 angles. We're going to set them equal to 720. You do. So I put parentheses.
Can you just sit here for a second?
I put parentheses around 2x plus 20. Hell, you got to keep writing, Betty.
I know, but I can't listen and write at the same time. I want to focus on one thing.
The parentheses, you don't have to have. I just put them so you could see the separate angles up there. You can put them or not put them, but with them you can count 6 angles. All the terms are along those. So we have to use that sum of the interior angles formula to know what to set our equation equal to. We add up all the x's, and when we do that, we get 18x. We add up all the constants, and we actually get 0. 20 minus 20 is 0. 10 minus 10 is 0. So this particular equation, sometimes that won't happen. Right, but it does happen here. So 18 times x equals 720. Divide both sides by 18. And now x is not the number of sides, right? It's not the measure of an angle. It's the value of x in this example. Try. Well, you're doing your sum on Alex, and I've not been collecting your work. That particular one, it would not be that hard to not write that down, but what if you had 18x plus 340? It would probably behoove you to write your equation, right? So yes, you should write that down. Do you have to put it in? No. Does that answer your question? Okay. All right, now 2 new formulas, but these don't work for all polygons. These only work for a regular polygon, so you're going to know what that is. A regular polygon is the same as an equilateral triangle. What do we know about an equilateral triangle? What do we know about an equilateral triangle? Root word equal, lateral, lat are your sides, right? Equilateral, equal sides. All 3 sides are equal, and all 3 angles are equal, right? A regular polygon, that's what it means. All the sides have to be the same measure. All the angles have to have the same measure. That's all that means. These formulas only work for those types. Right? So if we're looking at a triangle, then it would be only the one, only the equilateral ones. But it works for any polygon with all the sides are the same length and all the angles are the same measure. So we've got that n for the number of sides. And one interior angle. So remember what an interior angle is on a triangle. It's this one, right? Interior angle. On this rectangle, it's here, right? So interior angles are going to equal the number of sides minus 2 times 180, but then divided by the number of sides again. Look at the exterior angle. It's easy. It's just 360 divided by however many sides there are. Okay, if we want to find the measure of one exterior angle of a regular polygon, if it has 10 sides, 360 divided by 10, so now we know the exterior angle is 36. Easy peasy. You know why that works? That's kind of mind-blowing here. The sum of the exterior angles of any polygon always equals 360. If it has 100 sides, and we find the exterior angles of all of them, all the exterior angles it has, you add them all up, it'll be 360. The exterior angles in a triangle, there's 6 of them. When you add them all up, they still equal 360. Okay? So let's use these two formulas. Find the measure of each interior angle and each exterior angle of a regular dodecagon. Look at your list. What's a dodecagon? 12. N equals 12. So we're going to find the interior angle and the exterior angle. We're going to find the interior angle first. So I should have used a variable for that. I didn't, but whatever. The interior angle is equal to 12 instead of n minus 2, all multiplied by 180, and then divided by the 12. So we're just replacing the n with 12. Your calculator will do this just like that, but you do have to put a multiplication sign in here and a division sign for the fraction bar. When you do that on your calculator, you should find that a 12-sided polygon, a 12-sided regular polygon, all of the interior angles will be 150 degrees. Now, exterior angles will all be 360 divided by what?
40.
What's n? We wrote n right here. N is always the number of sides. Let's do the exterior angle first here. So you're going to have to type it in. That's what it looks like on your assignment. Find the measure of each interior angle and each exterior angle of a regular 40gon. What is n? 40. Gosh darn it. I keep doing that. Let's do the exterior angle first then. How do we find the value, the measure of the one exterior angle of a 40gon, a regular 40gon? Exterior, 360 divided by 40, right?
Yeah.
So now it's 9. The interior angle, we replace the n with 40. So 38 times 180, all divided by 40. Do that on your calculator, you find that one interior angle of a regular 40gon, remember they all have the same measure, is 171. Any questions? Last one? Is this the last one?
Yeah.
Okay. If you know the measure of an, you don't have to write that for now. I don't want to spend enough time. If you know the measure of an interior, don't talk while I'm talking. If you know the measure of an interior exterior angle, you can find the number of sides. The measure of each interior angle of a regular polygon is 44 degrees. So we're going to use this formula, but now we already know what the angle is. We're looking for the n. This is the formula. You don't have to rewrite it. For the sake of time, this is what we plug in. But this is the formula we're using. All right, so you're writing this. We know that the interior angle is 44 degrees. They tell us that. What we're solving for is the number of sides. So the easiest way is to turn this into a proportion. Remember how you do that? Just put the 144 over 1, so now we have a fraction equals a fraction. And now, how do you solve proportions? You cross multiply, right?
Yeah.
144 times n and 1 times that. So it's 144n equals n times 2 times 180. So now we have a pretty basic equation. It does have variables on both sides, though. How do we solve this equation with variables on both sides? First we're going to distribute. I forgot. Let's distribute first. Now we have variables on both sides. 144n here, 180n here. How do we get them on the same side? All variables on the same side.
Can it be negative?
It can be a negative too. Want it to be a negative? We always mess that up, right? So let's take the 144n, and what are we going to do to it with that? Subtract it from both sides. When we do, we're going to get 0 equals 180 minus 144, which is 36n. Does that make sense, Nisha? Does that make sense, Andre? Now, what do you do to solve this equation?
You add the 360.
Add 360 to both sides. So now we have 360 equals 36n. Now we're going to divide by what's being multiplied here. Divide both sides by 36. So now we know that there are 10 sides. Remember, you just wanted to multiply by 180, Kyle? 10 times 180 is not 144, right? So gotta be careful. You can't do it that way.
8.
Oh, actually, that's not the same thing. It would be
Minus 2, so it would be 8.
8 times 180 would be, yeah. But I gave you the wrong example there. You have to multiply this. It's a bad example, so forget it then.
Everything finished?